Go.
Okay, fellow Earth scientists, this is your test for the atmosphere in meteorology. We're going to do a quick review. It is so easy, we can do it blindfolded. Just be safe and stay indoors, okay? So let's start this test. Let's first talk about the layers of the atmosphere here. Remember we talked about with you guys that Trey stacks money tall, right? So we're going to start out where we live, here in the troposphere, where Trey lives, because Trey has my money and I'm trying to find him still. So Trey lives in the troposphere. Remember we talked about that here is the temperature at the bottom. This is cold, this is hot. This is altitude from sea level going up. So this is altitude on this side, height above sea level. So we live in the troposphere. All weather happens in the troposphere, remember? So what happens in this first layer where we live is the temperature starts to get cold as you go up in the troposphere. All weather happens in the troposphere. Then you get where the stacks part is. Trey stacks, that's the stratosphere. That's also where the ozone layer is. And the ozone layer, if you remember, protects us from ultraviolet radiation. That's why we buy the sunglasses that say 100% UV protection from the radiation from the sun. So the ozone protects us from that. That's also what makes this get warmer. So the stratosphere, it gets warmer again. So remember we said the layers of the atmosphere are divided based upon temperature. So the ozone layer is here. It protects us from ultraviolet radiation and everything's getting warmer. Now we get to where the money is, where the mesosphere is. Then all of a sudden it's going to start getting colder again as you go up in altitude. Then the last layer is the thermosphere, and the thermosphere gets warm again. So we get cold, hot, as Trey stacks money tall in the layers of the atmosphere. All right, so you got to know your weather instruments. The first one is, you guys all know this, the thermometer measures temperature, right? The rain gauge measures how much rain fell. Those are the two of the easiest ones. Now we get into the wind vane, where it gives us the wind direction. The anemometer, anytime you see the little thing with the little cups that spin in a circle, that's an anemometer that measures wind speed. The barometer just looks like a round gauge, like a clock. That's going to measure our air pressure. There's one more that's out there that may be on the test, and that's a psychrometer, and that's going to have two separate gauges on it. One measures the dry bulb, and one measures the wet bulb. If you see a thing that looks like that, that's the psychrometer. All right? So now let's talk about wind. We know that wind always blows from the high pressure, right, to the low pressure. So this first one here is a sea breeze. So you're going to see a diagram with the ocean and land. Any breeze that blows when the high pressure is over the ocean and it blows towards land, that's a sea breeze. It usually happens during the daytime. So what happens is high to low, that's the direction of the wind. So when we get here, it's warm air rises, right? And then it comes back around, it gets low again, low pressure sinks again, and it goes around in circles. This creates a sea breeze. The opposite one is a land breeze, where the high pressure is over land. And then, so the low pressure is over water, so it blows in the opposite direction. The wind blows from, still the same from high to low, but it's blowing towards the ocean, away from land towards the ocean, and just the opposite happens. That usually happens during the night. So a sea breeze happens during the day, and a land breeze at night. So let's talk about what happens when warm air rises. When warm air rises, we're going to get the 3 C's. So what are the 3 C's? It's going to cool, condense, and it's going to make clouds. And that's usually what happens when warm air rises. So remember we talked about low pressure systems out there. Low pressure, we're going to have bad weather. It's going to be cloudy. It's going to be rainy. So with low pressure, what happens is it's the more dense air is going to rise. So you get low pressure, so it rises and it makes all this bad weather, clouds roll in. High pressure is just the opposite. So we're going to get good weather. So the sun comes out. No clouds. And it's a nice day. So anytime you have high pressure, the air is cooler, it's more dense. It pushes the air down and pushes the clouds away. So you got to know low pressure, high pressure. All right, a couple more items on your test. What creates global wind belts? What creates global wind belts? So wind belts are going to be created by unequal heating and the Earth's rotation. Remember we talked about the Coriolis effect. The Coriolis effect is when the Earth is rotating. So we talked about that the Earth is moving, it's rotating, but the wind nothing holds the wind in place. So the wind appears to be rotating to the right. So that creates global wind belts. All right, so when did oxygen first appear on the Earth? So we're talking oxygen first got here, we talked about 3.5 billion years ago. We got our first photosynthetic organisms that made the blue-green algae. So we talked about cyanobacteria that produced our early oxygen in our atmosphere that paved the way for life to form as we know it today, that needed all this oxygen. So how does convection work globally? We talked about convection is the circulation, the rising of the hotter air, the settling of the cooler air. So globally, warm air from the equator mixes with cold air from the poles. So we got the warm air in the equator, it mixes with the cold air in the poles, and everything rises and settles, and it creates a convection currents and creates global wind belts. The two gases that make up our atmosphere, you got to know this. It's mostly nitrogen, so we're talking 78% nitrogen and 21% oxygen. Those are the two main, there's some other things in there, but those are the two main ones you got to know. So I'm going to turn it over to Miss Teven. She's going to talk about the rest of your test. I got to turn out the lights. We're going to come over here.
Okay, we're going to talk about air masses. Air masses are uniform bodies of air with the same temperature and humidity. Here are the air masses affecting the North American continent. Easy to remember. If it comes from the poles, the air masses will have a capital P for polar. They will be cold. If it comes from the tropics, from the equatorial region, it will have a capital T for tropical. If it comes from the water, lowercase m for maritime. Okay, it'll be very humid. If it comes from a landmass, it will have a lowercase c for continental, meaning dry. So, places where air masses meet are called fronts. So our first front is a cold front. Anytime you have advancing cold air, it's going to push warm air up. You're going to get a low pressure system, cooling, condensing, and cloud formation. Notice the symbol for a cold front, triangles pointing in the direction the cold front is moving. Warm front. Warm front, you have half circles moving in the direction of warm air. Once again, low pressure system. Stationary front, you have a cold front moving one direction, warm front moving the opposite. A stalled low pressure system. Occluded front, okay, occluded front is similar to a cold front. You've got cold air
Hope you went forward.
Following cold air.
You click the button.
Okay, so let's see. Elevation. Okay, sorry. Here are some factors that affect climate. Latitude. Look at this. 0 degrees. Low latitudes have high temperatures. Look at the data. You can see the highest temperatures are along the equatorial region. Colder temperatures are areas with less solar radiation. Elevation. Here's an example. If you increase in altitude, there's a decrease in pressure. This is Mount Kilimanjaro in Tanzania. At the base of Mount Kilimanjaro, you have very, very warm region. Notice the elephants. At the top of Mount Kilimanjaro, you have snow. Sorry. Okay. And our last one is proximity to bodies of water. Let me click to that. And you and I experience this. We live next to the Chesapeake Bay and the Atlantic Ocean. We are warmer in the winter and cooler in the summer. Why? Water has a high specific heat. Water takes a long time to heat up and a long time to cool down. Study for this test. You are going to have flashcards. You're going to make flashcards in class. You have this tool to help you study. No excuses. Do well.
All right, guys, watch this video once or maybe more than once, and good luck on the test. Don't do it blindfolded. I was just kidding.